Okay, in this video I'm going to go over chapter 11 problems, the first couple, which are basically just using the formula that the amount you have is something is the amount you started with, and if you assume exponential growth, it's some base to the x power. And x is often t because things usually grow with time, so often x is t, but not always, so you just write it generally like that. So a0 means at time 0. And you can use different letters depending on what you're looking for. So for example, in problem 11.1, they give us some numbers. They say in 1968, in 1968, which we're going to call t equals 8 because they're actually starting with t since 1960. So that's time is 8 years. The minimum wage was $1.60 an hour, which I believe is correct. I think these are real numbers. Then in 1976 it was $2.30. So 1976, which would be t equals 16, it was $2.30, and that's saying that 1960 t is equal to 0, and we don't know what it was in 1960. Okay, so what they say is assume that it is exponential growth, which it might not be, but if we did, and they say this is the wage. So for part A, we want to find a formula for W of t. The wage is a function of time, which we can write as W0, the wage in 1960 at time 0, times some base to the t power where t is in years. So that's what we're looking for. We need to find W0 and B, the base. That's the whole point of this problem, finding W0 and the base. Okay, so we have 2 points. You always need 2 points to solve these problems. We have 2 points. We know 1968, we know 1976. If we have 2 points, we can find an exponential curve. And of course we can find a linear model. That would be easy too, right? You just need 2 points, and you find the slope, and you assume it's a line. But you also need just 2 points for an exponential model. Okay, so let's do that. So what you do is just plug it in. Let's see, the wage in 1968 was $1.60, so you write $1.60 equals W0 B, and that's time equals 8, B the 8th. And then in 1976 it was $2.30, so $2.30 equals W0 B to the 16th. So our job now is to find W0 and B. And the easiest thing to do is just divide those equations. So if we divide those equations, we get 1.60 divided by 230 on this side equals W0B to the 8th divided by W0B to the 16th. And the W0's cancel, which is why I divided them, because those things cancel out really nicely. And what we're left with is 160 divided by 230, which on my calculator gives a really, really long number. So it's points, and you want to keep a lot of decimal places because it actually makes a big difference. So I'll keep a bunch, 0.695652, 0.695652 equals, we have a b to the 8th and a b to the 16th. The b to the 16th wins by 8, so that one cancels out. We have 8 left on the bottom, so 1 over b to the 8th. We want to solve for b, so we can switch positions. In other words, divide both sides by this, multiply both sides by b to the 8th. But the trick is you can always, if one's in the top and one's in the bottom like this, you can always just switch them. So we have b to the 8th is equal to 1 divided by 0.695652, which is, because I kept the number in my calculator, that's exactly 1.4375. That's what b to the 8th is equal to. But we want b, not b to the 8th. So we raise both sides to the 1/8 power, both sides to the 1/8 power, which is the 8th root. 1/8, remember when you multiply exponents, 1/8, b to the 8th to the 1/8, 1/8 of 8 is 1, so we're left with b on this side. On the other side we have 1.4375 to the 1/8. Again, on your calculator you can do that hat, or the little thing like this thing, to the 1/8 power. You might want to use parentheses. 1 divided by 8 when you raise it like that. Otherwise it might mess up, so you put 1.4375, that little symbol, to the 1/8 power. And if you do that, you get, again, lots of decimal places. I get 1.0464078, which I'll just write as 1.46408. Now we know what B is. So now all we need is what W0 is. So we can go back up to our formula then and use either of our points, since we now have B. So I'm going to circle that. We now have B. So we have that W of t is equal to W0, 1.046408 to the t. And we can use either one of our points up there to get what W0 is. So let's use the first one, 160. So 160 is equal to W0, 1.046408, and the wage is 160 at t equals 8. So I do that to the 8th power. So then W0, oh, and I'll just do that out right now. So that's, oh, of course, that's just going back to where there was our number up there, 1.4375. So W0 then is 1.60 divided by 1.4375, and I can just fit it at my piece of paper here. And that is, on my calculator, 1 over times 1.60, which is 111.113. I'll say 1.113, and that's what W0 is. So finally, our model then, I'll write it over here, is our wage at any time t we want is W0, 1.113, times our base, which is this big number, 1.046408 to the t power. So that is our final answer. And then we can figure out whatever t we plug in, we know what the wage is then, assuming this is the right model. Now, minimum wage usually doesn't grow as an exponential, but that's what, yeah. Okay, so then part B says, what does it predict in the minimum wage in 1960? 1960 is times 0. So for part B, it's just W0. It's just 1.113, the number in front, because that is the wage at times 0. So that's really easy. And then C says, if the minimum wage was $5.15 in 1996, is this model right? So what you do for part C is you plug in that T is equal to, let's see, 1996, so you don't plug in 1996, what's that? After 1960, that would be 36 years? I think that's right, 36. So I'll let you do that. Plug in 36 here for t, raise that to t power, and see if you get 515, which is what it really was. And that would be a good test to see if this model is correct. And you can try it for today. Plug in whatever t is for 2020, actually that's not hard math, that'd be 60, and see what the wage would be to see if this exponential model works. Okay, that's how you do 11.1. Not so bad. Then 11.2 is very similar, and you can do that one on your own. They give you the town of Pinedale, which I have been to, by the way. It's a cool town. I have a friend who lives there, and population boom. I was there before 1990, and back then it was 860 people, and 5 years later it was 1210. So you have the 2 points, right? You have 1990, which I would call t equals 0, because that just makes life so much easier. And then the population then was 860. It's always nice to make a little table like this. And then let's see. Pop was 860 5 years later, which means in 1995, so that's t equals 5. The population was 1210. 1210. Okay, so they say find a linear model, and that's pretty easy then. So for part A, and I'll let you guys do that, just find a linear model, find the slope, yeah, then use one of the points. Just these are your points, right? Make it easy. It's 0 and 860, 5, 12, 10. Fine, make a linear model. And then Of course, find an exponential model also. So we can call this maybe the population, so p of x, so we can call her p of t, and again it's equal to the population at time 0 times some base to the t power, and your job is to find p0 and the base. Now here's a really easy thing. We know what it is at time 0. At time 0 it's 860. So right away we know that P0 is equal to 860. If they give you time 0, that makes life so much easier. So now all we have to do is say that P of t is equal to 860 b to the t. And then you can use t equals 5, plug in t equals 5, population is 1210, and you can figure out the base. So that's pretty easy. And then plug in for part B 2000, what's the population in 2000, or plug in the year 2000, which is what, time t equals 10, and see what they say, how many people there should be, comparing the linear and the exponential. All right, so hopefully that works out pretty well for you. And